Hi and welcome to this video about writing a simple debugger. And when I say simple, I really do mean simple, at least for this video. So the first question you might want to ask is, why would you want to write a debugger to begin with? Obviously, you probably are familiar with many debuggers, or at least some debuggers like WinDebug, the Visual Studio Debugger, XDBG. There are many debuggers out there. So why would you want to write a debugger? Well, you don't necessarily want to write a full-fledged debugger. That's a big project, and of course there are reasons why to do that, but you might want to leverage the powers of a debugger to do certain things. For example, you might want to know when certain API is being called, look at their parameters, what they get, and even look at results after the APIs are being called. If you use a standalone standard debugger, you probably need to set up a breakpoint in that function, and then every time it breaks, you need to record the parameters in some way, and then you need to continue debugging. So maybe we need to use some kind of scripting capabilities that debugger might or might not have to accomplish this kind of task. Now imagine you have multiple or many APIs you're interested in, things get more complex. So if you can leverage some APIs, some powers that normally are reserved for debuggers, maybe you can do that in a way that doesn't require you to manually do all these kinds of things using a standard debugger. And so a simple debugger is going to be built here. We'll do that in two stages or in two different ways. The first one is going to be in this video, which is using the Windows Debugging API. See exactly what Windows provides out of the box as a way to create debuggers. And as we'll see, it's a fairly bare bones, which means it gives you very few ways to deal with debugger-like tasks. But we want to start with that to give you a sense of what that looks like and what we can do with that without doing too much work. But as we'll see, in order to provide some more information like accessing symbols, for example, setting breakpoints, things like that, this API is not enough. You have to build on top of that. And so in the next video, we'll look at the Microsoft Debugger engine that powers debuggers like WinDebug and see how we can leverage that engine, because it's really just an API, to create something much more full-featured that would allow us lots of flexibility if we need that. But let's start with our basic API debugger using what Windows provides out of the box. So I've created a simple application here, another console application as we typically do, and included windows.h and stdio.h to get us started. So when we want to write a debugger, what does debugger really do? The debugger needs to attach to a process. We can do that in two ways. One of the ways is by attaching to a process which is already running, and the other way is to launch an executable, create a process based off of that, and then attach to it. So both of these ways are possible to do. So let's start with the idea that we might need some kind of a process ID. And so we create a process ID by looking at the command line. So I'm going to look at the command line, assume that the first parameter of the command line is a process ID. I'm going to read it in. And the way to attach to a process is by calling a function called debugActiveProcess. So debugActiveProcess says that the current process, the thing that I'm writing right now, is going to become a debugger for a process given its process ID. So I want to start with that. So I can pass this PID here. Of course, if it's something that is illegal, this function will not succeed. So if PID is something like 0 or just an ID for a process that doesn't really exist, this is not going to work out. And so we can check the return value. And if it's false, it means that something is wrong. We can just return. So technically, we should probably write some error here, but let's just save some time by just simply returning. So that's one way to go about it. The other way, as I mentioned, is to launch an executable and then attach that process. So the way to do that is by using the create process API that we're familiar with from other videos, and just using a special flag as part of the flags parameter called debug process, which means that I'd like this to be actually a debugger that is attaching to the new process being created. And regardless of how we start the process of debugging, then the way we continue is the same. So let's go ahead and continue and see what that looks like. And so in order to continue being a debugger, we need to wait for something called the debug event. So wait for the debug event or the extended function, which also can be used, which is slightly better because it allows us to get output from the target process as Unicode, not just ASCII. So we'll go with that. And you can see it requires two parameters. It returns a debug event. Debug event is a structure indicating what has happened, what is the next thing that has happened in the target process, which is of interest to us. So it could be, for example, a thread being created, or DLL being loaded, or an exception being thrown. All these kinds of things are events a debugger process is interested in, obviously. And so the debugging API gives us that information. And then we can wait for some time. We can wait forever, which is what I'm going to do here. I want to wait until we get the next debug event. And while this is true, that is, while we have no errors calling this function, let's just continue running. And so this would technically be an infinite loop. We can try to make it slightly better. Maybe we'll have an exit parameter here. It's going to be false. So while we're not exiting, and we get some notification, then we want to do something. And we'll change this exit later on when the target process terminates. So if the target process terminates, maybe I'm not interested in continuing hanging on that loop, because obviously there's nothing going to happen anymore. So it's best to just exit the application. And by the way, it's possible for debugger process to debug multiple processes. So I can call this debug active process API multiple times if I want to, and I'll get debug events for all the processes I'm debugging. And if you're familiar with other debuggers like WinDebug, you know that this is something that you can do. We can debug multiple processes at the same time using the same debugger process. But of course, in this example, I'm just going to use one process for demonstration purposes. So once we have a debug event, what do we need to do here? And so what do we have in the debug event structure? If we press F12 to see what's going on, we get here a few details. The first one is the debug event code indicating what has happened. Is it a new thread, a thread being destroyed, a DLL being loaded? One of the several options that you can hint by looking here. And then we have the process and thread ID that relate to the particular event. So if I'm debugging multiple processes, the process ID here is going to tell me which process is the one that's responsible for the current event. So the first thing we're going to do is just going to display this PID and thread ID. And I'm also going to display the event number just for debugging purposes, no pun intended, because we're writing a debugger, which is again an application, we need to debug that as well. It might not work as expected. I'm going to use the Visual Studio Debugger for this purpose. So let's just write PID here and TID, something like this. And just to start off, so we have something to look at. So let's go with EVT, then we have the debug code, and we have, let's put it on a separate line, we have the process ID and the thread ID. So obviously the process ID is going to be always the process ID we attach to here initially. That has to be the one because we're debugging just one process, but still let's just write it properly. And then we can switch over this event code, see what has currently transpired, what happened, and do something about that. And so we have this bunch of values like create process debug event. So create process debug event is always going to happen. It's going to indicate that the debugger has attached to a new process. So obviously we have to get that as probably the first thing that happens. And for each one of these values that you can see here, we get an appropriate structure, which is part of a union provided inside debug event. So for a process create, we have this create process info member in this union that has the unimaginative name U, that has this structure with some more details about the process that we're now starting to debug. So that's some structure we need to look at in order to get some more information. And so in order to do that, I'm going to call a helper function, display a create process info or something. And I'm going to pass in exactly this particular one that is about process creation, like so. And then at the end of the switch, I'm just going to add a \n here. So I'm going to just write things without a \n, and then just move to the next line after we're done displaying whatever. So we have this function we want to fill in. So let's go ahead and do that. So this create process info has the structure create a process info or something like this. So again, we can go to the structure, see this is create process debug info. That's the thing that we need. So that's the one. So let's just grab this and want to do something with this information, of course. So let's see what we can get from this particular one. So again, we can look this up in the documentation, of course, but let's try to figure out some of these members are fairly intuitive and you can guess what they do. So first we have a handle to the file of the executable itself. And so this allows us to get more information about the executable itself. We have a handle to a process. That's the handle that has been created for our purposes for the debugger to that process. And so we can use this handle to do whatever we need with that process. For example, we might need to read the address space of that target process, of course. You're familiar with normal debuggers, we can see variables and memory and stuff like that. So how does that even work? We have to have some access to that other process. So we have this handle being provided to us by the debugging API. So I'm going to definitely save that for later. We also have a handle to the first thread in the process. And there's some other stuff, including an image name which is supposed to give us something about the executable path. But if you look at the documentation, it doesn't really say that this is necessary. You might not get it when you call debug active process. You actually do get it when you use the create process API with debug process flag. And so it's optional. You have to tread carefully here. So the first thing we want to do here, let's have a global variable for our process. Let's call that the GH process. Now, obviously, in a real debugger, or if you write code in a more structured way, you probably do something different in terms of how you manage all that information. But I'm going to do the simplest possible thing here to make things as clear as possible. So we're going to go ahead and grab this particular handle to process. So we have that. And we definitely want to display the executable name. That's something we might want to do. And so we need to look at info here and see what we have here in the image name there. And so if we have something which is not null, then we can do something with it. But if we do have a null, then we'll have to do something else. So let's call it some function here like display image name and provide this image name. Otherwise, let's try to get some information about the executable name using the H file. So let's call that display file path, and we'll call the H file, provide the H file handle here. So that's what we're going to do here. And of course, we can display other details. For example, we can display the load address, whatever we have that in info. There's more information here like the base of the image, the start address of the first thread. And so we can say, let's just do that, start address or like main thread start, and just display this value like so. So we have something, I'm not going to use \n here, just something like this. And now we need to fill out these functions, of course. This is something we need to do. So let's start with display file path. So here's display file path. We need to get a handle to a file, and we need to find the executable name. Well, actually the file name of that file. And so there are a few ways we can go about it. I'm going to use one way which might not be perfect, but should be good enough for our purposes. So we can use a function called get file information by handle ex. And so this allows us to provide a file handle and some enum indicating what we're interested in. In this case, we're interested in something called file name info. We'd like to get the information about a file in terms of its file name. And then we need to provide the appropriate data structure there. So what we need here is something called the file name info. let's call that info. This is what we actually need. However, this is just kind of a structure that only has the length of the file name and also the actual characters, but we see that the structure only accommodates the first character. This is typical in many Windows APIs, which means that we actually have to provide more memory in this area, otherwise it just won't work. So we can allocate memory dynamically, but I'm going to use another kind of a trick we can use by having a union here and just having a bunch of bytes here that we don't need to use, but because we have these bytes here, like max path times 2, then the union object is going to be, this is going to be actually the path, let's call that path. So the union object is going to be big enough to accommodate a path of length max path from a Unicode perspective. So now we can pass this info thing and size of info in a kind of straightforward way, and that's it. And so if this works, of course it might technically fail, but if this works, we're going to leverage printf and display the path. So I'm going to say path and then %ws, no \n here because we have \n at the end of the switch, and we're just going to grab info.path and try to display that. So we have the file name here and the file name length. So I'm going to assume the file name is null terminated. We'll see if it's not, then we'll have to do something slightly different. So that's going to be display, well, image name really, but file path. So that's fine. Let's go with call that a file path because it's really more of a generic function. It's not really about executables, and I have to spell properly. So we have that one. Well, I guess my bad. We need to display the image name. This is the display file path. Okay, like so. So what about the image name? How can we deal with the image name? So for now, let's just create a function for that. Display image name based on some kind of p-void kind of thing, which is kind of weird. And for now, let's just do nothing and see if we actually get called here. Let me just print something silly like image name, and that's it. And we'll see if we get there. I'm going to put a breakpoint here. Okay, let's go back to our switch. So we have create process. What about the opposite? So we have exit process maybe. So we have the exit process event. And here, what we actually get, if we look at the actual structure, we just get the exit code. So let's just display this exit code while we're at it. And we can set the exit variable to true to break out of the loop. And so I'm going to grab this evt.u, and there's exit process here. And the only detail is the exit code. So I'm going to just display that and break out. Okay, so that's kind of better. Let's try it out. Let's see if that actually does what we want it to do. That's we didn't test anything here just yet. So let me build that. And first we need a process to work with in order to attach to it. So we need to find some process with some ID that we can use. And it's definitely something we can do. Let's do that. It might not be very convenient because every time we stop debugging, we'll find out that the process actually dies out, which means we'll have to create a new one and then of course adjust the process ID. So we can perhaps create some kind of helper to make it easier for us to launch something and attach to it. But let's try this first. And so I'm not going to use, well, maybe I'm not going to use the debugger in my first try itself, the Visual Studio debugger that is. So I'm going to open a command window here. And let's go ahead and figure out the process ID for a notepad. So I've launched notepad, that's 33860. So here goes. I'm going to use simple dbg here, and already forgot the process ID, 33860. Okay. Here goes. So you can see that we get process ID, which is of course expected to be the same one. We have the main thread here, and we get something. but obviously something is not right here because nothing moves forward. And the reason for that is that we have to tell the debugger engine here, the debugging API, it's time to move on to the next event if there is any. And for that we have to call the function continue debug event. So this function has to be called every time we're done dealing with one event, otherwise the target is not going to resume and it's going to kind of be completely blocked. And so we need to provide the same process ID that we got, because again it could be that I'm debugging multiple processes here. And then we have some constant here which we need to use, and one of them, the simplest one, is dbg continue, saying, you know what, let's just continue with the next thing. So let the target process continue execution, and the next time there's something to say, then let's break again. So the wait is going to be called now after this continue debug event call, and we're going to wait until the next event comes in. So obviously we want to test that again, and again it becomes a bit tedious. So I've written some code here just to make it easier to work with. I'm just going to paste it here to save some time. And the purpose of this code is simply to create a process based on some executable path and return its process ID. And with that, we're going to call debug active process. And so if I go back here to main, instead of getting this process ID from the command line, which is probably something you want to do in a more realistic situation, in this case for testing purposes, I'm going to use launch exe here and provide something to launch. And so I'm going to have something here, and again we can just use something which is hard-coded, but of course it can be anything, doesn't really matter. I'm just going to launch this thing and we get the process ID, so we can pass it directly to debug active process. This is a normal create process call we've done multiple times in the past. We just return here the process ID on a successful call. If it fails for some reason, return 0, which will make debug active process fail, and so we'll exit the application. Okay, so let's try it again. This time it will launch a notepad automatically and then move on to waiting for debug events after attaching as a debugger. So I'm going to press F5 here. So let's go ahead and try that. And so you can see notepad comes up and we get various events. You can see the event for process create, which we technically expected. You can see that we get the path for notepad, or at least something which is close to that. And we get a value for the main thread start, which in this case happens to be 0. And so in some cases, some information might not be available exactly as we think it should, and we might need to use a different approach to find that information. And then you can see there's other stuff that is happening here, like a value of 6 and 2 and lots of 6 and 2 from time to time. And then we're here waiting for something to happen. And so if I go ahead and close this notepad, you can see that we get the exit process event, and we're supposed to break out of the loop. We didn't break out of the loop because I forgot to change the exit variable here to true to break out of the loop. Let me just put a space here because everything seems to be close by. So we have other events we have to deal with. One of them is the load DLL debug event, which of course is very important. Let's deal with that because it's a bit more interesting, and it will also, we'll see that we'll have to deal with this option right here. So let's have another case here for the load DLL event. So let's again call some helper function. Display load DLL info, and we're going to pass the load DLL part of the union where we have to dig through the information and then break. Okay, so let's give it a shot. So we have this function. We're going to get here something like load DLL debug event info or something. Let's see what we have here, what we have to work with. So as you can see here, we have the base of the DLL, that is the address in the target process that the DLL is loaded into. We have the image name here, and we have a handle to the file, again to use for any purpose really, but maybe to get the executable name if we have to. And we have the image name here, which we're going to use now, and then we have a Unicode here indicating whether the image name here is actually Unicode or ASCII. Okay. So let's see what we can do here. The first thing we want to do is definitely display, well, let's display the address that is being used to load the DLL. So that's something easy to do because we just get it. So let's just grab it because it seems to be easy enough. That should be the base of DLL. So let's just display that. And then we want to display the path of the DLL. So let's see. If info LP image name is not null, we're going to call the display image name info display image name helper function, which we have yet to properly implement. So LP image name. Otherwise, we're going to do the next best thing, which is display the file path based on the handle to the file. And so the first option is better because it's more precise. The second option is kind of a fallback if you have no choice. So let's give it a shot. Again, we'll launch a notepad automatically, attach to it, and then show what is going on. So here's what we get. We get here the address DLL is being loaded into. We can see anti-DLL is actually being provided to us by H-file, but then we have another DLL here being loaded, and the information is provided by that pointer. So the question is, what is that pointer really? So we have the display DLL here that called this. So we're right here, we're calling this with this image name. So what is that really? I mean, what is that pointer? So as it happens, this pointer points to another pointer in the target process where there is a pointer potentially pointing to the path. I know it sounds a bit complex, but the first thing to note is that this pointer is not in my address space. It's in the target process address space, not the debugger's address space. So if I go to memory and try to see what's at P, it's more likely, if I use P just here, that we'll get question marks indicating this is not a valid address in this process. It is not. It is a valid address in the target process. So we need to do something about that. So here goes. We have to read memory in another process, which is of course what the debugger does in many cases. This is how we can actually debug and see what is going on in another process. And for this we have the function read process memory. So really, read process memory is a function that allows us to read memory from another process given a powerful enough handle, which in this case we have, has been created for use for debuggers. Although we can use that in other scenarios, it is really for debuggers. So our base address is this P that we want to read, and what is supposed to be there according to the documentation is another pointer. So the pointer there, let's call that address, is supposed to point to the actual address of the image path, if there is one. And so we're just reading the size of a pointer. So it's a pointer pointing to a pointer, and then that pointer is pointing to a path. If everything goes as planned. So we're just reading these 8 bytes in this case, like the size of the pointer in that address space. And so we need to make sure this works. If this works, so the address is valid, it should be valid, but it's always a good idea to make sure. Then we can move to the next step, which is reading some buffer. And so here's where we have the actual path. So let's just go ahead and assume 1024 bytes as a maximum size for the path, and we have to use a read process memory again. So here's read process memory. Now we need to read from the same process, obviously our target process, but this time in address. This is where this address is stored to point to where the actual path begins. And so the path is where we want to read stuff into, and that's the maximum number of characters or bytes we want to read. And then we also can get back how many actually were read, but we don't really care about that in this little example. I'm just going to assume that if this works, I'm going to zero out this memory here, and maybe I should actually read 1 byte less or 1 character less if that happens to be Unicode, to make sure we have at least 0 there when we're making the actual print. So we need to print now the path, but this is slightly tricky because we need to know whether the path is ASCII or Unicode, and the way to know that is based on the actual information provided by the actual DLL event notification here. So in fact, we have to go to display image name and also provide info.f Unicode here. We have this kind of member here in F Unicode. Let's go back here and see what's going on. So we have this F Unicode here, which indicates whether it's actually Unicode or not. And so we need another parameter to display an image name here. So let's have a little boolean here, which is going to be called Unicode. So now we can do the printf properly. So we can say if it's a Unicode, then you want to interpret this as %s for the printf function. Otherwise, just a simple %s and not ws. So ws is for Unicode and %s is not for Unicode. And then we can pass in this path. And so we might want to cast that or something just to make the compiler happy perhaps, but it should work, even though the compiler might not be like fully happy about that, but that should be good enough. So we're passing here this Unicode, and this also applies to the process creation here. It also has this Unicode there. So we're going to pass that as something that's going to be converted to a Boolean. And now we're basically ready to go. Well, at least to some extent, we can definitely try that. So let's go ahead and give it a shot. Okay, so we'll land here just to show that in fact we get something here. Let's see that just once. So first we're reading an address. So here's another address. Again, this address is in the target process. There's no point in actually doing anything with that. And then we can read whatever it is pointing to. And now we get some kind of path. We're supposed to get some kind of path. And so if we open that path, we do see something. And you can see that this is a Unicode thing. So we can see C:, and then backslash and so on, Windows and things like that. So when we print that, if we go back to our console application, you can see this is actually C Windows System32 kernel32.dll. So that works as expected. Technically, I should be a bit more careful there. I need to make sure that address is not null here. So if it's not null, then we want to do the actual next reading. And technically, I can just subtract 1 in case it's not Unicode, but I'm going to not deal with all these details here to stay on track. So now we can remove that breakpoint and let's go ahead and run this again, see what happens. So you can see Notepad comes up, we see all these notifications, so we can definitely see that we have these DLLs being loaded, gives an indication about DLLs being loaded into the process. That's definitely good. So obviously we're not dealing with certain events like event number 2, which we'll deal with momentarily. So here's another thing that happens. Let's go ahead and open the file dialog box here. So many more DLLs are being loaded, and at some point you can see things get stuck. They seem to be stuck in an event ID called 1 with a value of 1. So that's kind of weird. So obviously we need to do something here. Something is happening. So if you go to the event numbers there, number 1 is actually an exception. So there are some exceptions that might occur in the target process, and maybe they're being held properly by the target process. And so the thing is that in case of an exception, you actually have to return something different here in the continue debug event function to indicate what to the debugging API, what to do next. So in fact, continue is not the right thing to do in case there is an exception. In this case, one simple thing to do is to say, you know what, the exception is not being handled by the debugger. Let's have the process deal with that in some way. And so that's the simplest solution to that little problem that we've seen now, that we get these exceptions and they kind of keep banging on the debugging API because we didn't say anything about how to handle the exception. dbg continue is not good enough in this case. So let's go ahead and try open again. And now we can see that we actually get to the open dialog box here, and we can see the notification. All that stuff is working correctly. You can see more DLLs have been loaded because of that open file dialog box. This is part of what happens when you open the open file dialog box. Okay, so let's close Notepad, and now we can see we break out of the application of the debugger. And obviously there's lots of events here we're not really dealing with. So let's deal with maybe another one, just for demonstration purposes. And so let's deal with a create thread notification. So here's a create thread debug event, and we're going to call a display create thread info function. that's going to get a create thread related data structure. It's called create thread. It's of type create thread debug info. Okay, so we're going to need to implement that. Let's do something very simple just to demonstrate the idea. So we have here debug create thread info something. Let's see what we have here, what we can provide with the thread here. Let's see what we have. We have info dot, and so we can see the start address, and we have a handle to the thread to do some stuff with the thread. For example, we can change its context to point to a different function. We have very strong control over everything that is happening in terms of threads because we are a debugger now. So let's just display the start address. And just display that normally with just %p, like so. Okay, so let's run it one more time. You can run it without the debugger now. Well, with the debugger, just not Visual Studio Debugger. So you can see the threads get created. There's a start address here. And obviously one thing that is sorely missing here, we get all these addresses, but we don't see any symbols. And this is where the API, the basic debugging API really lacks. That's one thing where we don't get any direct support by that API. We have to do something else. We have to use other APIs like the image help APIs that are provided for dealing with symbols, but obviously there's more work here to be done. And you might need to use other APIs, some of them provided by Microsoft, some of them maybe something we'll have to write ourselves to get that extra information. Let's go ahead and open the file dialog box again. And we'll notice that we have many new DLLs as before, but also new threads coming up. And again, we just get addresses which are just numbers. There's no symbol support directly in the debugging API. And this is one of the reasons we want to use maybe a higher level API to get information. Other things you might see that are missing is how do I set up breakpoints? Is there a breakpoint API in this debugging API? And the answer is there isn't, because a breakpoint is a high level facility. How do breakpoints really work? And the way debuggers implement breakpoints is by exchanging the instruction when you want the breakpoint to hit with an int3 kind of instruction in terms of Intel AMD processors to force a breakpoint. Once that breakpoint occurs, the debugger gets an exception because the breakpoint is really a type of exception. So dealing with exceptions is actually very important. I'm not going to do that here because this video is long enough. But technically you want to deal with the exceptions because some of the exceptions are actually breakpoints. And so in case of a breakpoint exception, then the debugger, typically what it does, it exchanges back that byte that was overwritten by that int3, and it looks like we're just in a normal kind of code. So obviously you can implement this kind of thing because you have full access to the target process. You can use the write process memory API to change a byte in memory where the instruction is supposed to break by putting an int3 instruction there. You can do that, and this is what debuggers typically do, but obviously it requires extra work. So that's just to show you that the bare bones debugger API is really bare bones. It provides just the essential facilities, but doesn't provide you with all the high level aspects you might need. And so other APIs are available, but obviously this is not a trivial undertaking. And so in the next video, I want to show you how to write a simple debugger with the debugger engine, the one that powers all the Microsoft, the fundamental Microsoft debuggers like WinDebug, CDB, NTSD, and KD. But for now, feel free to play with the debugging API. It's fun, and you can, if you are up to it, up to the task, use the image help and other APIs like the debug help API to get some information about symbols and stuff like that.